we should start with today's training session. First of all, thank you for everyone that is joining us today with this training session dedicated from the SEACAP for SDG project on the selected outcomes from the project references. Today we have with us once again the Medicosur project and the outcome selected from Medicosur that is regarding the tool of retrofit solutions and the cross-border living lab. Today we have with us Mr. Juan Camilo Olano from the University of Florence, and we're going to talk about the BIM methodology, and that is considered to be the best path and what has been done within the Medicosur project. So thank you all of us once again for joining us today. I believe Dr. Juan Camilo Olano, you can start with your presentation and of course to showcase us this excellent BIM methodology. Thank you.
Sorry, I was not able to unmute the microphone. Hello, thank you so much. Well, I'm gonna show you about the BIM process and how and why it could be the best path to develop single projects of refurbishment or any type of project, being new projects or something like that. But the important is to understand that it's a complete different process that is structured, is thought to be organized, and may change completely the point of view on how things have been managed up to now. It's not more difficult, it's just more organized, and we have to take care in consideration all these matters to avoid having problems in the future, because we need to talk a complete similar language with all the projects, all the people and roles involved in a project. And that's the only thing, and that's why it's interesting, and that's why it's something new for many of the ones involved in the project. So, as I was saying, we talk about...
Yeah? I'm sorry. I don't know if you have realized, we can see all your screens, so we can also see, except for the presentation, a Google folder. Maybe it's not your preferred option.
Sorry, yeah. Hold on a second.
I'm just stating for your convenience.
Yes, but you told me about what?
We can also see the contents of your Google Drive. This time we're seeing your Google Drive, not the presentation.
You are seeing the Google Drive, not the presentation.
Yes.
Hold on a second, maybe. I shared the wrong file. Now you see the presentation?
Yes, perfect.
Okay. I don't know why I was sharing the other screen.
You were saying all the screens, so we're seeing both the Google Drive and the presentation. Now we see only the presentation.
Okay.
It's perfect.
Sorry, I got lost. Okay, then we've got a complete project. That the project is what we think is, and it stops at the end of the construction process. But it's not that way how things should be seen. We've got the building life cycle, that is a step-by-step process that goes through all the planning process, construction process, but one of the most important parts of the building is its life, the operation process, which is the longest period a building is on and it's working and it's been live for our environment. but we never take in consideration that part. And that's something that must change, because we develop very nice, good projects, very efficient projects, but during the maintenance and operation processes, if we don't take care of what we have done, it very fastly get damaged, stop working as it should be, and we really have the performance of the building lower its level. And sometimes it's really a pity having very nice and beautiful and what was supposed to be a very efficient and technological building completely forgotten and going into ruins. So one of the main causes of this problem is the lack of information. Why? Because we don't have the information at the end of the project. Yes, we have the as-built drawings. Then you have also a maintenance manual that is a huge Bible of 1,000 pages that no one will read. No one will apply what's written there, because if no one reads it, no one will apply it. And that's why our buildings are getting into a very difficult condition, are very expensive to maintain, and are very energy wars. So information is what allows us to understand the building, to manage the building, to plan how to make it more efficient, how to renew it, how to make it better, how to modify it for a new, different use. So if we don't have that information, how can we plan, or how can we maintain something that we've got as an asset? And imagine that it's only one building. It's difficult. If we put it in a condition of a university campus, as the ones that we have been thinking of, the amount of information to be managed goes to infinite. So if we don't have strategies on how to manage this information, we will never change the real condition of how these buildings to perform. So who is intended to live in this? The building life cycle process is dedicated to the building managers. Building managers means in terms of teams of people working together, reading, understanding, managing information that may come through the life of the building and that comes from the construction process, from the planning process. So they have to mix up both informations. They've got to understand where we have the problems, where we can just act in a different, in some specific way, or here or there, where we can just get more profit in terms of energy efficiency, or in terms of best solution for the goods of the students or the teachers, or the specific use that we require in terms of operational matters regarding the university campus. I'm gonna be talking most of the time referring to the example of a campus, because it's what we're intended to work on through the MedGreen Forum, the Med EcoSure project. Sorry, cables are crossing down. So as I said, all these 6 phases have to be thought, have to be planned, have to be always going around. It's a cycle. It's not something that starts one day and finish one day. The day that a building will not work anymore for what was intended, we can just refurbish it, we can change its use, we can modify it internally and make it again something useful for what are the purposes of that specific moment on a campus or on the normal life of the university. Or maybe they can sell the asset to another thing to be modified and to be used as another part of the city life. But we have to intend that one of the most energy efficiency and sustainable processes is to give life to what has been done in before. So the six steps or the six phases are the plan, the construction, the use and maintenance, the repair, because during the life we have to repair the building. There's always something to be done, small modifications. Then we have to learn about what happened up to a point, learn from those lessons, and plan it again. If we learn from what we have done, we will really improve in the future processes. But if we don't have information from where to learn, it will be difficult to plan and make properly new plans in the future. So I don't know how many buildings do you manage there, but I think that the properties goes most of the time over 10 buildings. If we do one, we learn what has been done. We have the information, we really share it, because that's another thing that is important, is the collaboration, the sharing of information, and the contribution of every single member of the team. Then what we've learned, we can apply it better on the second building. Then even the third one will be even better. And then we'll be always try to get better things and better results. What we can have all this information together. We can collect information from many different parts, also during the life of the building. We collect them through the planning and construction process, but the building doesn't stop there. It's live. We can have another type of data, another type of information connected to this information that we already got, to enlarge this knowledge of our buildings. We can use it also through a digital twin implementation. So why are we thinking of something that is, we are talking about managing information. We are talking about poor knowledge of building consumptions. We are talking about a knowledge of building components and materials, difficulties or inefficient maintenance and operations of buildings, and all the planning and renovation processes that are not cost effective. Because if we don't have the information of all these things together, how could we plan something? How could we really target to get something and really understand what we are planned is intended to do something and achieve it? And this is how the big problems we are having now, also here in the university. We've done a survey. We try to understand how they manage all the building assets in the university. And believe me, these four elements, these four matters that I'm showing here are the most representatives of the big problems that we found here in the university through our research and trying to understand how things are. In this survey, we enlarged it also to other entities, other universities who are managing assets, and the problems were nearly the same. So the lack of knowledge of the information, the lack of uniformity, consistency of this information is one of the most problematic matters and things that we've got. Because one thing is to have the information, one thing is to know what it is, one thing is to be able to use it for something useful. And maybe, yes, we've got some information, but we have the information not because it's in a specific person, because structure are where things, how to get into the information is open it server to have it. Just to mention here, all the managers, all the infrastructure, process, the MEP installed, all about the lighting, all about the building structure, its constraints and everything. Somehow, in terms of constraints, because are not part of them, they were informed of it. They just told us all the constraints. When we got about regarding the MEP plan, it was chaotic. They say, no, don't worry. The guy will go there, arrive here. I'm the one responsible for all the mechanical matters in the entire university. There's no problem. Ask whatever you want. I will reply to you because I'm the one who knows everything. Then we ask, okay, we need to place a sensor and we need to know exactly the size of the heat pump. The heat pump. Do we have a heat pump here? Are we sure we have a heat pump? Then he goes outside, the other side, looks upstairs. Okay, I don't know if we have a heat pump here. He said, yes, we have fan coils. If we have fan coils, somewhere there's a heat pump that should be installed. Okay, I will see. Then he didn't even know that there was a heat pump. He didn't know where the heat pump was. He didn't know the power of the heat pump. So he was the one in charge. He was the one who knew everything regarding the mechanical plant. And that was the answer we've got from them. Completely nothing. He went to the office, he opened the folders, and he called me. The folders are empty. I don't know anything about the plan in there. Of course, we found the heat pump, we found everything, but it was not in the hands of the ones who were managing. The bills arrived to the office, they paid, but no one knows really about the consumption. How can we control the consumption in terms of lighting, in terms of heating, in terms of aircon, in terms of water supply, in terms of hot water supply? No one knows. They just pay. And I believe that is somehow what happens in most of the cases in the other universities, in the other big how can I say, structures that got lots of buildings to manage. I want you to say, if you want me to stop, you want to make any questions, please stop me and make the questions. It's not something that I would like to talk by myself for 3 hours alone. It would be even better if I received some questions during the process. For example, now I would like to ask you, what is BIM? What do you know, or that someone knows exactly what building information modeling means?
I can answer that if you don't mind.
Yes, please.
BIM, as you said, is building information modeling, and is considered a process to create and manage information on a construction project. So, and we can also view the project life cycle as well. So we can use a module to make a digital description of every aspect of a building. Is that a good answer?
Yes, it is the right answer. Because
okay.
there is no right answer. There is no wrong answer. If we answer in the way you did it, because we talk about information, you talk about process, because it is what it is. It's just a process. It's not a software it's not just a model, are containers of information that are part of a process that goes through the planning, construction, and life of an asset. And that's how it is. So the important thing is that it's an integrated project that has information from many different roles, from many different inputs that are not only the ones who are planning, are also coming from the ones who are going to operate it, are coming from the ones who owns the asset. So we've got plenty of different directions from where the information comes and how we can just process this information and use it through all the different phases of the building life cycle. As the funny thing is that the term BIM continues to evolve, because over the years it has been always changing, because from the different points of view, according to the phase, according to the use of the different kinds of information, the meaning of the BIM has been evolving. But it's interesting to know and to see that it's coming something common, and understand that it's a process. And it's very nice, because the first time that happens to me that someone answers right. So thank you. So when we talk about the building information modeling, we talk something that is related only to the architecture, engineering, and construction industry. It's a process that could be only applied to our world. It's not something that we can apply for any other industries. They've got their own management, the other ways of manage their own information. We've got here the BIM only for our industry that is construction, building assets, and our built environment. Information, as it says, is the soul of the BIM. It's in the middle, it's the soul, and it's everything about the processes and the use of that information during all the different phases and the management of it. And then the modeling is now that we talk about models, we don't talk anymore about designs. But we are not talking about models or geometric models. We are talking about information models. That is something different. It's completely different than what we've got in mind, because a model many times is used as a 3D model, and it's just one part of the information we've got. That is the three-dimensional information of a geometry. But we've got plenty other matters of information that are part of our models. Then we will see, and it not only, this regards not only the building, it also regards the infrastructure. The other very important thing that we've got is the collaborative process. Why? Because we, up to now, we have been exchanging information in a traditional way. I need a drawing, I send a DWG. I need something else, I send you a PDF, a Word file, through mails, through, now we use also the Drive in the folder structure that sometimes is not even well known to everybody. We don't have a control of what we share, how we name it, who I have sent the information, the one who was intended to receive it. There's a bunch of thousands and thousands of emails, messages. Now we've got also WhatsApp messages, vocals, photos, to exchange information. But how this information, these exchanges of information could be registered? How we can keep a track of what really improves the process of a project. It's difficult to see, to understand. Yes, sometimes it's easiest to take a picture and send it to the builder, said, please, this thing has to be changed, what's up? But if he had the cell phone off, then arrived the other one who never received the information, they have done the things differently, and we cannot say that the information was sent by a WhatsApp message or that the information got lost on an email that was not written by someone. And how things has been done up to now, at the exchange of different communications, sometimes not putting on the loop the other persons who were maybe interested on something and we were not thinking of. Just to make an example, the other day I was on site. We have installed all phone calls in rooms for now hotel that's opening. Everything was perfectly done. Everyone was happy. It was properly done, the installation. And when everyone was about to celebrate, then arrived the sound consultant, said, but when you installed this, why I never received any information regarding. But why? Because I need to measure and I need to be sure that these fan coils will not make so much noise that will wake up the clients during the night. No one thought of putting him on the loop. The exchange of information went out here and there, and the tests of sound installation on the cameras were never done because he was never informed that the equipment was already on site and was installed for testing. It means a problem. It means a problem when someone stays out of the loop, even if you think that it's not intended to know, or maybe someone forgot just to put him on copy on an email. It may carry some problems at the end of something. The other way, in the BIM process, we've got everything all together on a common data environment. It's called common data environment because everyone should be in there. Everyone should have access to it. Everyone should know exactly how the files are named, where the files are, and that's written. That's a project Bible. So if there's a doubt of where or how things are, you just take that document, you open it, and there are all the instructions that allows you to find a drawing, a document, a model immediately. So you can just check, share the information with whoever needs to receive it in real time. So you don't need to call the architects to ask for a document. You don't need to call the cost manager to see if he had received something. No, the information is there. Everyone knows what it is. Everyone should go there and take out the information required to develop its own work. And that's completely different way of working. If we've got rules, we know where things are, we know when things have been updated. So I don't send you the information. We just know that every single Thursday, the information will be updated. And if I need to check things that has changed, every Friday I can go and check. That's, for example, is just an example of how things should work. Of course, we don't have to wait for a week to make a new issue. If there is something that has to be changed, we can just change it and communicate. Emails do still exist. A phone, it's always welcome. A phone call is always welcome to share, to combine, to project. But if we have organized the other things, all the other ways of communication are intended just to improve and the speed of the process. so we can get better results of the planning, the construction, and the management process and phases. All these phases are divided in sub-phases, but these are the main phases where we are always talking about: design phase, construction phase, and operation phase. If you see the image in the bottom, the operational is always bigger than the other ones. And when we've got a proper building information model intended since the beginning, we can start with all the construction and manufacturing process during the design specification and also during the operation. This is the model that usually happens when we used to rebuild, because we are not starting from scratch when we have to start on the specifications. Before, after we've got the first stage, we start with the second stage. And after we've got the second stage, we start with the operation and maintenance phase. In the case of a refurbishment, that is mainly what we usually do here in Europe, since we've got plenty of buildings and all the campuses, on many campuses are inside the cities, we already have the buildings. So we start from there, but with a building that's occupied, a building that is serving to different operations, different matters regarding the education or other things. And we plan it, we build it, and we operate it, while everything is maybe the only moment that the operational part of one specific building may stop is in here, but the operation of the entire campus continues. So somehow everything goes in the same line. Just to somehow understand, when we talk about the information on a model developed by a BIM authoring model, is this. We've got the CAD 2D, and it's a bidimensional representation of a geometry. We've got also the CAD 3D, that is the thing that up to now we believe a model is, that is a three-dimensional expression of a geometry. And then we've got the BIM object. The BIM object that seems similar to how the CAD 3D looks like. But the real difference is that we've got plenty of information connected to that specific visualization. And I mean visualization because we've got geographical and geometrical information that allows us to represent that information in terms of a three-dimensional visualization. But the real aspect, the real value of all this is what is there, but we can't see. And what is what we can't see? We've got up to 12,000 cells of information to fill up per single element that we've got in a project. 12,000 is too much from my point of view, because to manage 12,000 cells of information per element on a huge building will carry so much information that I'm not really sure if we can really manage all this. So it's important also to understand which information is really required, which information do we really need, which information are we going to use and will be useful for the operation, for the construction, for the planning, for the future. So if we understand that, that's the information that we may require to be placed on a model. And according on the phase that we are, this information may get richer, may get used, and at some point, maybe that information will be not useful anymore. So it can be reduced. For example, all the, according to your your use of a model, do you think the cost of a material is important to be filled up inside a model or not? Who can answer me that question? No one?
Can you repeat the question, Juan Camilo, please?
Yeah. Do you believe that it's important to add the cost of a material on the BIM model? Or not?
Cost of a material.
Yeah, the cost of a material, the cost of a component. For example, the cost of a brick, or the cost of a door, or the cost of the drywall by square meter.
You mean the financial data in general?
The financial data, yes. Yeah.
Yeah, but not financial data. I'm just talking about the cost, because the financial data is different from my point of view. But I'll explain you now why.
I would say yes. If we need to have a financial, economic estimation of the building.
Okay.
Or it would depend on what we would like to evaluate at the end. If we'd like to focus on the cost or the investment of our renovation project, or more on the technical parts.
Okay.
I don't know.
Now, I said that for me, the cost is not the important thing. Why? Because today we've got one cost. We take it from the price list. We introduce all that for the matters of the financial evaluation of the costs of a project. So then we can determine how much a project will cost. And that's fair enough. The problem is that we carry out with a huge research information. We put it on a model, and tomorrow those prices will change. We don't know when or how the prices will change. But if we put all the financial information in a way that we can connect it externally to a price list, we can just update in real time the model information, the financial information, with a price list. So that's most efficient in terms of usage of information than just making a lot of research on a price list that tomorrow will change. I don't know how things are now in Tunisia, but or in Greece, but at least here in Italy, the prices in the last 2 years have been rising a lot. I started a project 2 years ago. Since we started up to now, the drywall has raised its price by 80%. And we received news that in the next 2 months, it will rise again between the 18 and the 20%. So if we put the cost on the model, we cannot just, it's some information that will get, it will be a huge effort for nothing. It's better to have the big effort to place some code, some information on the models that allowed us to connect directly and link it externally to a cost management software. I don't know if I start explaining the idea of it, but it's
sorry, Juan Camilo. So the idea is to couple the BIM with an external program or software that's able to introduce or insert the costs of each or link each component with a cost.
exactly.
And then, yes, okay.
Yeah, but somehow we've got every single role got its own tool. I cannot ask the cost manager to analyze costs of a building from my BIM project because he used Excel, just say Excel or some other planning and sheet documentation, where he can just organize all the costs and the values of the different parts of the project. So I cannot just give him a model because he will not do anything with it because it's something that we as technicians know how to deal. But if I give him an Excel file,
a template of
extracted from the model and connected with the model, because the softwares are connected with it and can export part of its information in Excel, for example.
Okay.
So I take the Excel file, I work on my Excel file, and I can just re-upload the Excel file to the model, filling up most of the information that we don't develop in there, because it's useless for us as as architects or engineers to fill up all the information. You know, it's too much information that cannot be part only of the one who's making the project, because we know how to develop, I don't know, a space, walls, windows, things, but costs is another one. Procurement is the procurement engineer who does that. The one who does the structural information may do it by itself. So then we put all together, all our information. We can have federated models. We can got one single model with all the information of all together. That's something that goes through the process, and we define it how to do it. But then we can just put everything in information containers. And then we will have, yes, the visualization of it, but we will have plenty of information that we can just manage for different purposes through the different phases of the building life cycle. What I mean, BIM is not only a model. It brought a lot of new different terms, different documentation, different specifications. And now we talk about all of this. For example, the CDE is a common data environment. We talk about the IFC, that is the exchange file for the open BIM. We talk about LOD, that is the level of detail. We've got the class detection, the COBI. And COBI is the way of exchanging information between the project model and the asset model. In terms between to exchange information from the project to the operational phases. So, but that's only in the UK, which means we've got all new terms, and all these terms have to be adopted, have to be assimilated into our life as project directors, as project planners. And we have also the new BIM dictionary, because it brought so much, but then everything is written, and that's what's helpful, because we can just go there, look at it, learn from it, and the first time we learn something, the second time we go there and look at it again, the third time we already know it. We already can repeat it, and then it will become part of our process. I'm not saying that we have to change everything tomorrow, and that from tomorrow we can just take our procedures and throw it away, but we need to start changing little by little, and little by little, step by step, we can make the difference. So what is your opinion regarding the digitalization in the architecture, engineering, and construction industry? Do you think it's something that is well developed? Is something that is underdeveloped? Do you think that is well positioned in terms of other industries, or badly positioned regarding other industries at the moment? Well, no one answers, so I'll go through the answer. Here we are. We are only above the agriculture and hunting industry. It's terrible. It's really, really, really a bad situation in terms of digitalization. It means that nearly every single industry in the world is above the construction industry. It means that what we are doing, it's pretty badly done in terms of what the world is pointing now, in terms of digitalization, management of information, IoT, ICT, and all this world that is now guiding, because if we like or we don't like, it doesn't matter. It's the way how the world is being guided, and it's the way that we need to adapt and move towards it, because we cannot just keep living in the Middle Ages. Middle Ages happened 500 years ago. Now we need to move forward. But somehow, if you think that the way that we are managing construction processes has not changed too much from the Middle Ages, and the quality that they had in the Middle Ages were farther better than the ones that we had today, from my point of view. So this is always something that is very nice. Who wants change? That's a real question. Who wants change? Everyone wants change. Do you want change?
We all do.
We all do.
For my part, for my myself, yes, sure.
Yeah.
Of
But
course
then-
we want change, but the thing is how we have
How?
to change.
Yes,
Yeah.
maybe
but then
everyone wants to change.
who wants to change? And then it's when everyone.
No one,
to
no one.
change and
No
to
one.
change.
Yeah.
Because it's easy. We want change.
We want change.
Everyone else,
Yeah.
someone else does it for us. Welcome. But if we have to do something for that to come through, is there where we find ourselves in trouble. And how we can change this point of view from the people, how we can just get the commitment of the others to make their own effort for the change to come. I think that's the most important thing that we should build up and try to bring the other ones into our side, because I know that you are keen to do it. You are trying to do the change, but we need to bring all the others together with us to make that happen. And why the beam? Why? Because there are directives already done, and it's something that is very helpful, that the European community established somehow that the public bids and projects have to be developed using specific electronic tools, such as building information electronic modeling. This is something absolutely good, because they said already, at least someone in terms of normative, in terms of regulation, started to think about it. And you know, somehow the change is not determined by the goodwill of people, but by the obligation or the restriction that the law has to be applied. It's not the way I like to do things, but somehow in some cases it helps. It helps because now I think these things are starting to change. A lot of work is starting to come through the people and at least starting to think about how things may change. It's scaring for many, and I know, but there's something there. There's also another thing that's very important, is that there are now international standards. International standards that may guide us how to do it. There are international and national standards. So if we don't know how to do it, you know why we are doing, there is someone, there's normative, there are guidelines, there are standards that helps us to go step by step, following this, following that, to get somewhere, to explain us every single step that we should do to get somewhere else. Then, of course, there are the private standards, because we, as people, as organizations, we take the international ones and create our own standards. We develop them and we organize them to keep the track of what we need in our own organization, in our little companies, or in the organization as the universities, just to understand how things are. We could just go through the pyramid. So up to now, we've got these ones, and then we have to create our own. These are the private ones. And this is where we should get to develop our own, to work together with our teams. There is the Building Smart entity that has been working on the standardization, on the terminology, in the process, just to make these things together for everyone. So there are plenty of different standards that has created all the information exchange. And there's also one huge international organization working behind it. And as you can see, they've got plenty of different documents that allowed us to make the process more efficient, and are still working on improve it day by day. We've got also the new BIM dimensions, because up to now we have talked about the 2D and the 3D that are the geometrical part of it. We've got the spatial data, we've got the specifications, we've got the aesthetical elements, we've got all the components, the layers of the different compounds in the entire building. We can have all the information of the performance in different terms of every single package or element inside the building. But then we can have also the planning, the schedule for all the construction process, which is something new, because we've got all the information, and if we've got a real good planner inside, will guide us to understand all the timing. And you know, timing in construction means costs. Good planning will help us to understand for how long we will need to be working on a construction process, how many people. We can plan properly, that it doesn't mean that we are not going to have problems. But if we plan it, we will have little problems that we can solve it day by day. But if we don't have a plan, if we don't have an organization, if we just have a program, sometimes not linked with the material, with the element, we say, okay, walls, 3 months. But walls 3 months doesn't mean anything. But if I know that I spend 2 hours per square meter of plasterboard installation, and we've got, with the quantities of plasterboard at the end of the day, we have 3,000 square meters. We multiplied, and we know exactly the amount of hours that we will require to install all that. If we then divide it by the amount of people that will be working, and then we put a 10% or 5% extra time just to have somehow air and not be very restrictive, we will have a proper plan. But then we need to be sure that 10 people should be present on site. And if they somehow have been working with 8 or 6 people for 2 weeks, then we need to ask them, the team of the plaster board, to increase the amount of people from 6 to 14 in the following weeks, to be sure that at the end of the day, there will not be delays in the planning process. So it will allow us also to control the planning. Then we've got also the budget. The budget is also, is what we were talking before. I don't put the price of the elements inside it. I create a 3D model with the information that can be linked with a cost head. So easily you can take the information, we can filter it, we can just place it in there, and then automatically the software for the evaluation, the cost, economic and financial matters will produce the cost effective, the cost results, and all the variation in the cost according to the different variations that we can apply to a project. It's been an hour. I don't know if you would like to have 5 minutes pause or you want me to continue.
Yes, I think we can have a short break, 5 to 10 minutes, and then we can continue in order to engage all the participants with your presentation and the relevant questions. So 5 to 10 minutes break, everyone, and then we will be back to continue the presentation. Okay?
Okay. Okay.
If everyone is back, I believe we can continue with your presentation. Juan, you don't mind me suggesting? I think we should continue. So we were talking about BIM, and now we will continue with the information requirements.
Yep. Does someone have a question, or shall I continue? Okay, I will continue. So when we talk about the requirements, and then we go in how we can apply all these system and procedures to our projects and to our organizations, it's something that, as I barely explained before, there are all the standards and the elements that allowed us to understand how we should organize the entire process, how things go through, and how we can come out through a process. So we've got all the organizational information. So it means from organization, I need to understand where I am, what do I have, how I would like to move forward, how I can organize and manage my information. And with this starting point, I can start to develop project information requirements. Project information requirements means what I do need for a specific project, what I would like to get, what I would want to achieve from it. And we can have all the asset information requirements. Asset information requirements in terms of operational maintenance and occupancy of a specific asset. With these 3 levels of information, we establish all the exchange information requirements that are all the specific requirements for a specific project, which means this is where all the architects, engineers, and everyone who may develop the project itself and make it real should comply with what was asked from the organization, the project requirements and the asset requirements, and how they will reply to it with the project information model. So here I give them the advice of what information I do need on the model, and they will give me a model for the different phases I required. And this project information model at the end of the construction phase, after the handover, it will become the asset information model that will have all the specifications I gave in here. So it's how the cycle will go through. So this is the organization, all the information we've got, all the assets, but we need to start serving all this information. We need to start organizing and planning. That's something that is now not happening anywhere. It's easy to not to develop projects, it's just easy to solve the problem the time it appears. Then we've got these two different levels that are coming from the organization. That is the asset requirements. How do I need the building, the project to perform? What and how I am going to be operating, how much it costs to maintain it, and all the project information requirements. This will create this exchange information requirement that will bring as a response the project information model. And then it will become the asset information model. What is important is to understand that we always said about the project, but the project itself is only this little, that is the delivery phase. It's called the delivery phase, which means I start here with my project, is the starting point of a delivery project. We've got all the development, which means planning and construction. And then here we've got the handover. Once we have the handover, we have all the operational phase. All this is already standardized. There are the books, the manuals, how the guidelines to follow. And then you see here, all the delivery phase is guided by the project information model, and the operational phase is guided by the asset information model. Imagine all what I said up to now, which could be applied to one specific project, how complicated it will be to manage a building asset, as for example, the one of the University of Florence, that is about over 300 buildings. And 20% and 25% of these buildings are buildings with cultural heritage constraints, with a lot of problems and difficulties on a UNESCO context that have to be managed in such a way where we should somehow have its information, and we should know exactly how they are, what they are, how we can deal with it, how do they perform, if they are good or not good spaces, comfortable spaces for the use of a university, for a campus. Are they adequate? Are not adequate? We don't know. We have plenty of it, but no information regarding it do we have. And then we've got such a very valued patrimony that it's a pity not to have the information to be sure that we can succeed on keeping them in the best way and in the most energy efficient way in terms of possibilities, because being constrained, being a heritage culturally, we cannot just go on there and do whatever we want to make them more efficient. They are there because of a reason, and we have to deal with that, but we have to use them the best we can to keep their cultural value and to make them efficient and useful and comfortable nowadays. But then, yes, we talk about all these documents, but we never talk about what does it means in terms of specific data. So when we talk about the organization information request, we talk about the interoperable data, a handbook, a BIM manual, all the analysis, all the measurements, all the performance of the building, all the intentions of planning, all the costs that the organization may have. When we talk about the project, we talk about the project coordination, the risk analysis, the planning plan, a project definition, BIM strategies, BIM dimensions. When we talk about BIM dimensions, we talk about the 2D, 3D, 4D, 6D, 7D, which means we can talk about, we are keen to proceed with information regarding the cost, the planning, the sustainability, the facility management. So if we have this in our mind, we have to start organizing the information for that, but also is the interoperable data that we have already organized on top. Then we've got all the asset information, which is data management, performance data, maintenance requirements, operation program. And then we've got all the documents and how are the exchange of information that we are going to produce. All the files, the type of file, documentation, quality assessment, quality control, milestones, decision points. And then we translate all these 4 elements on a model, in a model of information that will be guiding a project, a planning project, a construction project, which means it will carry on a lot of information that are going to be documented, are going to be graphical and non-graphical information that will go through the asset information model with the performance data, the maintenance data, all the products and all the materials that have been installed, all the warranty data, all the exchange method, because also I need to be sure that the way I place the information on the product is something that I will be able to read after it, that I will be able to manage in terms of management. So in terms specifically, I will explain in ArchiCAD, because our project was developed in ArchiCAD. Since I'm an ArchiCAD user and I'm an ArchiCAD BIM manager as well. So we decided to do it in ArchiCAD because of my fault. And then it's how things are. At the organization level, we've got the BIM manual that contains all the office documentation, all the architects documentation, all the outputs, all the standards that we used here in our lab. And then we translate it into an ArchiCAD template. So every time that we open a new file, every time we create something, we've got all our standards already there. So we don't need to think about how to name a layer, how to name a file, where to save something, because everything is already there. It was planned, it took time to develop, but the translation from something that is written to something that is physically useful as a tool is already there and it's being done. At the project level, we've got all the project specifics, all the inputs that we've got from there, and then we translate that into a project specific developed in ArchiCAD. So there are 2 different levels of information. There are 2 different ways of translating this information, and what we've got as an organization standard, somehow we put it here, we use it always this way, and then we've got the way to translate the specific project into a project model. As I said, the BIM manual is the first thing to start, because we need to understand how to operate. We need to create a common language between the ones who are going to work together. So as an organization, we need to start talking together the same language. And we started from us. Then we enlarged it to the different teams that collaborate with us, but they somehow, or they fulfill with our standards, or for a specific project, we can adapt some of these standards to make them equal to the standards of the other team, so that we can just work together easily. But if there are no standards, there's no way of communication, there's no way of exchanging information, and there's no way of working together. And this is how things are now. I guess many times you have opened a DWG file with everything on the layer 0, or everything with different naming that are completely incomprehensible, not comprehensible for most of us. And how can I read a document? How can I read a drawing, or how can I edit a drawing that is completely unknown for me? If I don't really know how to do things, or how to deal with the information I've got in front of me. So this is important. We've got everything there. We've got the roles, the responsibilities, all the documentation, all the project workflow. Everything is already there, it's written. Every time we have to start a project, we have to start from here. And if there's something that has to be changed because of the interaction with another, with the others, then we modified maybe not our BIM manual of the organization, but the BIM manual for the specific project. And remember, this BIM manual has to be the Bible of the complete organization. Everyone must follow and comply with it. Otherwise, it's like having a crazy ball just bouncing over a space, and will create problems. You cannot communicate fluently with someone who replies you in Japanese. We just talk in English, or between us together, we can understand that we all of us talk in English, even if it's not the most fluent language, even if it's not our first language, but we try to follow the rules of the language. We try to make it as clear as possible for the other one to understand. But if by any reason you talk to me in Japanese, or if I talk to you in Japanese, all the communication will get lost. So somehow, this is how things are, and how we should proceed in a process, in a BIM process. There are all the information exchange phases that are exactly the same. We create all our steps, our milestones, our deadlines, phase by phase. We have all our controls, and if we follow the cycle, it will be, there will be no problem of it. At the beginning, we've got less information, and the level of information will grow up to the end. And I'm talking about information, not the level of development of the geometry. Because at the beginning, we start from scratch with something. We just have lines. All these lines with the normal development in the project will become something else. Materials, then it will go to finishes, then it will go to real elements placed on site, because I can't determine at the beginning which are going to be the tap of the sink that will be placed in the toilet of a project. I know that I would prefer some specifications of water flow that are the thing that concerns us in terms of operational matters, in terms of consumption, but we don't know the brand, we don't know the type, we don't know the shape at the beginning, or not even in execution, before the execution process. Maybe during the execution, the construction, things change. They comply with the performance of the element, but not with the specific details of what we suggested. So then when they give us what was really installed, we need to update the information. And then for the operational and use life of the building, you see the information will not really grow anymore. It grows a bit, because if I change something because it gets damaged, if I define there are damages, there are new requalification of specific areas, because now we don't have one classroom, we need meeting room, then we change that space for a specific reason, but we are not refurbishing it. We are just modifying the layout, interior layout of the building. If we can just update that information will increase the amount of information that we will carry on the building during the operational phase, but will not be as much to really change the amount of information that we've got in the project. So we've got the cycle, we've got all the different phases, milestones, and deadlines. We also have to define the process. Remember that this is a general information that it could be this way, it could be in a different way. I'm just bringing some specific roles that will be part of the project, but we can start from the phase 3, for the phase 4, just construction, since the planning, it depends on how we organize and how big is the project and how we develop the idea of the development of it. So we've got the different roles and the different states of the process, and how we should interact in which specific phase, in which specific task, and who is going to contribute to that specific matter during the process. So if we got this since the beginning clear, we can just plan it properly. We know what information we need to provide to whom, when, how, and where. So it's good enough. The same in the different phases of the building cycle, since the planning to the operation. So the owner is always present, the organization one. The architect is the first one who starts the project, then starts all the engineers, but look, but here is very different, and it's something that we never took in consideration before. To place a facility manager at the design development phase. The facility manager usually arrives here when everything is done. So it means someone who is going to operate the building, who's going to maintain the building, who's gonna deal with the 90% of the building life cycle, never takes part of the planning, construction, and development of the project. Here, things change, because now he is giving his input on how the building should be managed, should operate, should be maintained, to the one who's dealing with the project. He's giving advice. So it's some information that since the beginning, we as planners have to put in place to understand how the building should be, how our refurbishment may take in consideration all these matters as part of the project constraints. as are the fire and security and prevention constraints, we should have all the operation constraints as well, because are the ones who may signify important money savings, important energy savings, important operational matters that will allow the building to stay in its place, in its condition for more time. Which means that we have to be proactive and not be reactive. Up to now, we have been managing and everything in a way of the reactivity. It's damaged, the window is broken, just change replace the window. Otherwise, we never do like that. And the same is in the terms of the software. We have to have a strategy, we have to study, we have to move forward, we have to start with a smart planning, we have to get deeper, we have to introduce more information, we have to understand which is the information needed, we need to understand how we can put that information, we should understand how we can exchange the information to make it simpler to the other ones, to extract information from our model, to enrich our model with their own information. And that's it, because we have to understand that a building project is not a selfish project. It's a collaborative project. And if we understand that, it means that we are not going to be against our teammates. We are going to be pushing all together to the success of the project. We are teammates, we work together, we are together in the same boat. We are not against each other. So we don't need to pinpoint, we need to collaborate, we need to move forward all together. We have to define also the responsibilities, which means we've got to check. This is the example from the architectural point of view. So we need to have visual checks. We need to check that everything is right in the right position, because it's easy. You just need to place something, insert a data that is wrong, and then you rise, for example, you've got all the elements 10 centimeters above the floor level. But then you have to check it visually. You have to create also instruments inside the software to check that information and geometrical information is right. You've got also to check the different rules, the different elements, the clash detection. You have to make also the code detection. Code detection means if I have to leave all the corridors for a fire escape route of 90 centimeters or 120 centimeters, I have to check them. But it's difficult if we've got a huge building to check all the simple corridors and to be sure that there's no mistake in none of them. That's why we use rule sets that can be applied into a different software, a software of code controlling of that is called, for example, in this case is Solibri. I don't know if you have heard of it. If we've got all our information pretty well organized, we put that information into another software who runs the rule sets and will check that the building we have developed complies with that. But when I said the rule sets are not the rule sets that I will establish, are the rule sets that maybe an administration, a local administration requires, also the fire department, also the engineering rules, the civil engineering requirements, for the anti-seismic regulations, water consumption, lighting consumption. There are many constraints, many normatives, many rules that we have to comply with at the time that we develop a project that may carry lots of mistakes at the end of the day. But if we organize our information, we can check that on a digital model. It means that we can save lots of money, lots of time on the site, in the construction process. And remember that most of this information we can carry out for the asset information model, and will allow us to be sure that we will always comply with what is the local and the national normative. We've got also the standards check, and we can check all the different elements, all the different layers of information that we create to be sure that we are complying with what was required in terms of organization, in terms of project, in terms of asset information requirement. And of course, this is from the architect point of view. And we said, you see, they were always talking about data set completeness and correctness. That is what we are exchanging, information. We need to be sure that all the information we are writing, we are putting on our model, goes to the other hands in a proper way. Which means when I write a letter in English, everyone who knows English may understand it. If I write something that the other ones will not understand, it's not English. And it's exactly the same in here. If we put the information in a different way as the way it was requested, it's exactly the same as having not the information in there, because the information will never be written and will carry exactly the same problem as the problem that we had at the beginning, that we had the information placed in different servers, but if it's not accessible to everyone, it's the same as not having it. That was for the architects, and that was exactly the same that happens to the engineers and everyone who makes and takes part of the project. In terms of project information production. We talk now about the coordinator, who may have different types of control. It will control a visual check of the 3D information. But if you see here, we have changed the tools. And as I said since the beginning, it's not a matter of a BIM authoring software. It's a matter of having lots of different software that can connect to the information we are putting inside our models to check it in different ways. So I can check, for example, models in here. I can make the federation model that comes from the architect, from the mechanical engineer, from the hydraulic engineer, from the electrical engineer, from the structural engineer, from the facade specialist, from all the different teams and roles involved in the project, and I can put everything together on one model to check that there are no clashes, that there are no interference between one model and the other one. And if there is something that is wrong, I can communicate them with the BCF file. The BCF file is something that creates a track, that creates a visual photograph of what was detected in a model that is wrongly done, or what needs to be corrected, or what needs to be completed. And this work is done by someone who is coordinating all this federation, and it's there not to be part of the production of the project. It's just to control the quality of the models produced by the different organizations working inside a project. different teams. This BCF file, we can make a comparison of what was the revision cloud that we had in the past. So somehow we clouded where there was something that was not properly done or needed to review, put it a number, and then we create a comment on what was there inside the cloud. Now we have everything in this file. Of course, and all the interference check, we've got the clash, the code check, and all the different checks in between the interaction of the different models. Then we've got the manager. The manager will check that all the standards, all the elements are in the same language. So it's important to understand and to share the time that we share that everything is clear for everyone. And then the most important thing, that the data set is complete and clear. Everything in the same file, everything in the same form, in the same way, with the same language, with established codes. Everything will allow us to succeed. And as I said, don't be scared to start a project through a BRIM process. I don't ask you to start with a hospital, a third-level hospital, because it will be crazy to make the first project in one of the most complicated types of project. But start from something. Start from a small part, and every time make it bigger and bigger. Of course, we need to start in the process of organization. We've got all the timeline and the tasks. Who is going to be doing what? Which team is going to be doing what? Who's going to be coordinating? And you see from and here we say the stage that are the phase. So every time we have to be there checking and checking and checking. We have to check since the beginning. We change the phase. We will increase the level of information. Increasing the level of information, we will require to be always checking that the new information that we will be adding, because that's the information maturity. The information grows while the project develops. So all this maturity and this development requires always to be under control. Let's explain a bit how it is simple in a sort of way, and how of what I have been talking about in a sort of graphic point of view. The building is somehow up to now called as the CAD evolution. The CAD evolution, we start with the normal lines that we were used to draw with our pencil. Then we've got the 2D CAD that is up to now, because it is up to now the way we are developing projects, mostly, not everywhere, not always, but mostly, still around, I don't want to say a number, but I think it's around 75, 80% we are still working this way. Not even this way, which is geometrical 3D without real usage of that information. The 3D is done many times by external entities just to develop the renderings, not for the study of the space. And then we've got the information model. Information model that, as we said, we've got plenty of information that are there. We've got building properties, relation, machine interpretation, everything is or could be inside it. So it's not just a normal evolution, because the evolution stops here of the geometry. Here we are talking about not geometry, we are talking about information. And when we talk about information, it means that we can produce the different levels that we would like to. And if you see here, we have a complete normal representation of a 2D drawing that are going to arrive on site. This is the kind of information that we bring on site to build up the a building, full of information, full of notes, full of whatever it is. But remember that this is only done for the purpose of the construction. But the information that it carries out is furthermore than the one that arrives there. But this is an extract from an information model. For what? For the purpose of a site. And we can go as deep as we want with a different type of details that we want. But we are working always on a 3D model with all the information, and all this information that you see here is the information that is inside each specific material applied in the different elements that we've got on a building that will be part of the asset information model. With the model, we can check plenty things, and that's what I was telling you. These are the most common uses that now are being applied for on a model. And this is, for example, the code checking and the clash detection. In these cases, for example, we were reviewing the window openings of a building. Windows openings that in these cases were clashing. So it means that if you see there is the model, we turn off all the other layers. We kept only on the windows, and we measured the window clashing. And here in these points where the building bends, we had the clashing. So it means you have to move the window towards the other one, or we just should keep only one of these windows operable. The other one should be shut forever. So then we avoid the problem of the opening clashing. We can check also the type of usage that we place into a model, just to determine what are the different spaces, how we connect the different elements, and the functionality of the building itself. So all these are rule sets run in the software of control, just to evaluate if that's the way the building should perform. And we are not talking only about energy performance, we are talking about functionality, we are talking about elements of operation, we are talking about authorization and the regulations of city normative. We can also have the visualization of it. We have all the different elements that are part of the building, how we should arrive, how the services may bend to avoid the clashing with the structural elements, how they develop their routes to arrive to the ceiling, how they move in the ceiling voids, where are the critical elements where are placed next to the man traps, so that then if there is a damage or there is something that needs to be replaced or maintained, we have them closed for maintenance and to replace them, instead of having, because we had, in this case, we had a full plasterboard ceiling. We have all the lighting, and we have placed only a few man traps holes. And we organize a way, we have all the machines of the lighting organized and properly installed in a panel with the codes of each single light that maybe can damage one day. So instead of having them all over the ceiling, we had them organized in one specific place. We had them here. They open the man trap, they find all of them with the code that is connected to the light and to the maintenance code and the facility management code that will show up the alert, so they know exactly which element they might go and replace. So there are many uses that we can take out of it. We can have also the quantities takeoff, that is something related to the financial and budget matters, because if we know the numbers, we've got the codes linked to the specific price list, in 2 seconds, we've got the variation. If we remove 3 doors, the following information takeoff will carry 3 doors less. The price list will automatically update, removing 3 doors from the multiplication of it. So these are the main uses of the model. But how we create this? Because up to now, it seems that this is easy, but it's complex. It's something that we can do, but how we can achieve it? With a standard data collection, understanding that we have all these 12,000 cells available for us to fill up with information. But which type of information are we going to fill there? Who I am or what I am. So we need to set, you are going to be a pillar, you are going to be a concrete pillar, you are going to be a steel pillar, you are going to be a beam, with which objects I will interact with. You are going to be a structural element, you are a bearing element, you are going to be interacting with the beams, with the foundations, which are my parents, my children, in terms of different elements that may appear of it. For example, all the profiles, the support profiles for the connecting joints of the steel elements. You've got the foundations, you've got the connecting, the joints, other elements connected to the specific element, the geometry. But if you see, there is only one of the different elements of information that we've got. All the geometry, that means where I am, what are my dimensions, large, width, height, different shapes, everything. All the properties, how do I look like, all the characteristics, all the finishes, all the elements that might apply to it and make it look as it is, and all the further information that is required. For example, it has to be fire rated, not fire rated, it has to be of a specific material or specific color, or whatever we do require. For example, also the warranty, the producer, the cost, the cost code, not the cost of it, but the cost code that allowed me to connect with the price list, the planning code. So all this information is what we are going to introduce here, all the metadata codification. And when I'm saying about codification, is because we, as organization, have a standard and define that every single pillar in a sort of way should be named and should carry some information that we define it in interior, that we are sure that we can manage, because it's useless to go into a very deep detail if we will not be able to manage. But for sure, we want to know which are the material or the compounds of all the envelope, the elements on a building. So if we've got that information, we can start understanding the performance of it inside, we can measure it, and then mixing up all the information, we can decide how we can act on that specific element or in that specific building to improve the performance or the consumption or the quality of the space inside that building. And when I said that this is an information container, this is how things look like. All this, we can see it in terms of geometry, a 3D element full of different stuff that we may know or may not know what they are. But then we've got all these elements that we are going to fill it up. Those elements are bearing elements, non-bearing elements, are interior elements, are exterior elements, are of which material, are related with the floors, are walls, are ceilings, are false ceilings, are furniture, are fixed furniture, are sanitary furniture, are part of the electric plan, are part of the mechanical plan, what they are, how they work, how they do interact, which are their sizes, what are their energy loads, which are their transmittance, what are the level of transparency of the glass. All this information we can add it to each of these elements. We can introduce it this way. We have all these elements and all this information. You see here is one cell and one cell with a question or with an element name, with a property attribute, and then we've got a cell to fill it up. All the elements we fill it up, we can export it from here. We've got here all the production data, who is the producer, who sells it, internet website, email, telephone, and we've got the element. The element in the detail, the 3D, what it is, how it looks like, all the information we want. And we need to remember that we have also the classification, because if we have a model where we have elements as I don't know, a chairs, but the chair was designed by me or modeled by me, and I've got them, I did it using pillars and slabs to create a chair. Yes, of course, I did it. It's fine. It looks like a chair. But I use some tools that if I don't change the classification, and I have to change them to say, you are not furthermore a pillar, you are a chair leg. And the model should understand that because I need to give him the proper information. Otherwise, when I extract from my model all the pillars to be placed on a price list or in a programming software, there will be 4 pillars running around with improper code that will not find a place on the price list, a place on the programming, but are listed as pillars. Why? Because at the end of the day, who brought the information in there never changed the classification, the information, the attributes of those pillars and make them furniture legs. So this is somehow a stupid example on how things are, but we cannot believe that is the BIM authoring software or itself that will recognize everything by magic. We still need to be sure that we give them the proper attributes, the attributes that we needed for the project. Also, as I said before, something that is very important is the way we have access to the data, all the data management. Data management means there is a server, there is secure, it's an FTP, it's a drive, whatever it is, it doesn't matter where FTP, where you want to save the information, it's fine. The important thing is that it has access to everyone. Everyone has access to information, but everyone who might have access to that information should have access to it. Because at some levels, there are very important or private information that not everyone may have access to it. So that one should be restricted. But the non-restricted information should be available for everyone, which means everyone should have clear the common file naming, the common data archive, the unique folder structure. Everything should be clear for everyone. And if we use remote drives as FTPs or drives or servers, we need to be sure that there are cybersecurity. Because according to the amount of data and privacy, we do require to be sure that that information will not fall in the wrong hands. And I'm telling that it's simple that if we work on a project as a small staff building in a university, the level of security is one, but somehow if we are working on a military university, the level of security should be even more. And if we talk about a military airport, it should be the top level of security that we should manage. So, of course, it costs, but according to the amount of information and the quality and privacy of that information may have, we should work on that, on the security of it. Then we've got all the transfer of information of that model into something that we call now the digital twin. It's a very complex term because it has been used badly, wrongly, and in a good way as well to determine something that many times people are not really, does not really understand what it means. And the digital twin is the virtual model of some real asset that are connected in between for a purpose. So I can see, I can read what is happening on my building in real time through a digital virtual element who, for example, can show me that in a specific room, we've got 35 degrees and show me an alert. Then I have to understand why there are 35 degrees on a room. Maybe there's a problem with the aircon. Maybe there's a problem with overload of people on a room, which means it's full of people. No one has opened the window. The hot weather outside is too much, and there is no aircon working. So it means we can understand what's going on in real time with the building, and we can try to solve the problems in real time, but also we can start getting all this information in terms of operational matters, in terms of behaviors of people to be predictive in the future. And the understanding of the asset, it means that we have to monitor, we have different performance. We have a normative to be compliant with in terms of lighting, in terms of ventilation, air quality, in terms of sound insulation, to perform in many different ways in terms of comfort for a specific usage. I don't know, but for sure, many times you've been on a classroom, the shape of it creates echo noise that is disturbing while you are trying to hear a lesson, or the lighting, some points when you are very close to the window is too much, while in the other part is too dark. There's no balance in between the entire classroom. You hear good in some positions, in other ones you don't hear anything. Sometimes you cannot see. It means some cases we have got very good classrooms where do like to have lectures, and some others where we really don't like. And we try to avoid those lessons. If we are there, we are thinking of something different instead of getting there. And I'm talking about university cases. Sometimes they have low ventilation, so after a few minutes you feel that the air is very dense and is complicated to continue. You get distracted, which means it's not really like. But we are just talking about subjective information. But if we place sensors, if we are able to measure, if we are able to understand exactly how things are, it will allow us to plan, to improve how the buildings and the spaces do perform. And this is how what we have been using here. We've got this monitoring system to allow us to understand what we've got, how it performs, to make predictive scenarios for the future. And it is. All these prediction scenarios will allow us to get somewhere, to get simulation, to get cost-effective analysis, and everything that we are doing and we have been doing up to now. Everything has started from an information model, and we took out all this information we converted into information available for the different processes and collaborative elements that we developed through the time. So if you want to have another 5 minutes break, or I already kill everyone.
No, don't worry. We are still working and keeping track of your presentation, of course, and the information you have provided us regarding BIM and how it can be used and the legalities. And I think at this time we can have a small break once again in order to give a breather to the participants as well, to gather any questions they may have, and in order to continue with your presentation. As I can understand, we are going to talk about air and air quality in a building.
No, air is the asset information requirements.
No, okay.
It's something very important to understand, because we never thought about the maintenance and the operational part while we develop the projects. But I do believe, or not me, we here in the lab, we do believe that the most important part of it's from there, because it's how the building will perform in the future. So if we try to change that point of view and we make the building managers believe that this is the most important part, and they introduce all this information on the project requirements, the project will become better and will be on top for further time. That's why.
That's an interesting point that for myself, I haven't given it much thought about the air and how it can be calculated, as we can say, and given input regarding this measure. So after the short break, we can further discuss it. You can give us your input and how you in your lab had this studied and how it can be implemented. So we are going to have a small break. I will be back in 5 to 10 minutes. So
Okay.
thank you very much.
Thanks, you.
Do you think we can continue now? We
Yes,
can
I
continue.
can. Are you ready?
Yes, we're ready. So thank you very
You
much.
think you will
We can
survive?
continue. We will try. Don't worry.
Okay.
Let's discuss about the area that you mentioned is something specific that
All right.
you want to introduce. So thank you very much.
Okay. Okay, so just start talking about the asset information requirement. There's a lot of information that should be part of it, and as I just mentioned before, it's something that should be taken in consideration from the planning part. During all the planning period and the phase, we should need to think about what is going to happen after the day of the handover, because all that comes after that, all the information we built up since the planning is what we should work on for the entire building life. So all the maintenance, the demarcation, the work instructions, all what was the contractual information that should be part of that information as well, and the risk assessment, all the commercial information about the description, the function, where it comes, which is the supplier, everything that we were talking before, because now we know where we bought the things, but the buildings will stay here after us. So it's important that we leave a track of what is there for years and years, for ages, because tomorrow we are here, tomorrow we don't know. Maybe we change employment, we move to another place, we get upgraded in our company, and we don't take care of that specific matter anymore. But if the information is there, everything is neat and clear, whoever comes after us will be able to continue having access to that information. And if we ask, and we have placed the specific bulbs of the Philips brand, we could be able to know the exact element we have installed, the exact supplier, the contact details, everything related with one specific element. Also, the performance indicators, we've got all the warranties, all the data sheet of specific element who should be working. Then if we monitor, it should be doing as it was during the FAT test, the site test, and during the operation period. If it's not, then we go for the warranty. And if we've got all that information in our facility management model, it's the way that we can control it, and we could be sure that everything goes in the right way, and as it was thought and planned. All the financial information for the original cost, the operating cost, the maintenance cost, because it allows us to plan. Because if we do have all this information on a specific model, we know that on the 5th year, on the 3rd year, we should have some costs. So we don't have to wait until the fan coil breaks down to replace it, as we've been doing now. We know that at the 3rd year, we should go there, change the filters, change everything, review the connection, do some cleaning of the fan, refill the gas, whatever it is, and then it will stay there, not for 3 years or 5 years, but maybe for 40 years. So it's also important that, but also the cost of this maintenance, it will be planned at the beginning of the year as a budget cost. So we know exactly how much we will expend on a maintenance process year by year, element by element, leaving just few surprises. Because I'm not saying that because we do plan the maintenance program, nothing will break. It's impossible, and I cannot guarantee. But for sure, if we plan everything and we maintain as much as possible everything, the extra cost by non-planned breakdowns, it will be manageable. So that's the point where we should get to. Also in the other elements, all the finishes, all the commissionings, all the design parameters, all the dimensions, everything that we required for the specific management of the building. So we've got all these elements, all the different levels of information that we should place or request in our models and during the project, so that our model will arrive carrying out all this information. And if you see, there's very varied information. It's not something that we can just say it comes from one side, comes from the other. It depends only on one specific type of file. We've got from alphanumeric documentation to planimetric documentation to photographs to codes, whatever it is, but it's how things are, and it's the amount of things that we can just put inside our information containers. And as I said before, the air should be reflected in the AIM, that is the asset information model. So all that thing that we suggest as a building manager, facility management, asset manager, maintenance manager to the project planner, it will be reflecting here. So then we should have all this data there. But how we should put that data? We, as an organization, should give them the idea of how to codificate this information. So we are the ones who decide our standards of function, how we are going to function, how we are going to operate, how we are going to filter information, how we are going to manage that information for the different purposes. So we will have remote monitoring information for what? For a real-time management, which means we will require a digital twin, which means that we will do something specific to have that visualization for something. We would like to have the replacement dates. For what? For elements. So how we are going to achieve that in terms of exchange of information, and we should do it. All the connections, because as we said, we need to understand how things are, how is the procurement, with which terms I should plan the replacement of the entire lighting fixtures of a university, for example, of a campus or a building. Then it's a lot of money, but it's not only a lot of money, it's also a lot of work, which means we have to plan. We don't need the entire amount of elements that they want. So maybe we need some fixtures that they want, the other ones after 30 days, after 60 days, after 90 days. We can plan the complete replacement in terms of timing. So all these elements are there, and then how we can manage this. Remember that all this model, we will put it in different softwares as well to manage that information. And as I said, we should be able to enrich, modify these models with new information during the time, but not modifying the building itself, the model itself in terms of geometry, but in terms of information. which is something strange because I'm saying that someone who does not will work on a software of authoring, a BIM authoring software, will be updating and modifying an information model. And it's true, because there are specific ways of changing the information, changing also the model, but not changing the geometry. We are going to be changing the information itself. Of course, we can change the geometry as well by writing it, but we'll need to be software engineer somehow. Let's talk about quickly, because I think we are running out of time, about the UNIFI case study. So, as I said before, we start working on the knowledge framework, because for us was very important to understand exactly how the data management was managed inside the university, how was the big complex of the university in terms of building assets, what was the complexity of it, just to start understanding which are the problems that the building managers have to face day by day. And knowing that, starting from that, that is the first X-ray that we should do to ourselves to understand exactly where we are. Because if we don't know where we are, it's very difficult to make the first step towards what we want to do or how we would like to be. So we start from there, we make a survey, because we were not really sure of only having the example of UNIFI. We share it to other universities and other entities. It was a sort of successful survey because we've got some information that was really good to understand how things are, but was very sad for us in terms that we understood that there's no knowledge of anything. Even if the building asset that we are talking about is over 300 buildings, there is no one who knows anything about them. There is a software dedicated to archive all the building information of the entire complex. And what they've got, there are 2D drawings, DWGs of the building plans, only floor plans, and they've got them because they have to use them for the fire escape routes. That here by law you have to place in the different parts of the building, showing how you should escape in case of emergency from that building. So they built up a 2D drawings of all the floor plans of the buildings. And that's the only information we've got of all the buildings in UNIFI. No sections, no facades, no nothing else. Quickly, this is the complex where we are now. I am exactly here behind this window. It's a very old complex with all the periods that came through the 1300s and have been changing the building. Is protected by the UNESCO heritage context. So we have got plenty of constraints in here. Here in the lab, we start thinking of how we can break all those barriers: the lack of information, the building constraints, the complex bureaucracy, the high energy consumption. And we start talking with everyone, with the public administration, with students, with the building managers, some other colleagues that are architects, teachers, energy managers. And we put all together whatever was in our knowledge as a think tank. It doesn't matter, because the good ideas can come from whoever can think. And we think that everyone is able to think and contribute. And that's one of the most important things, being collaborative, not being competitive, because we are not in a war against anyone. We are just enriching ourselves with whoever wants to give us a hand to increase and move forward. So that's our main beliefs, and we're still working like that. To start, we start with this small room that is around 100 meters. That is nearly symmetrical to this one, and we've got another big room on top of us. These are the rooms that we would like to work on at the beginning, and we are monitoring this specific one, and then we will measure also the other ones. As I said, we plan in a very circular process, because it's not a linear process. It's something that starts, ends with the intervention, with the handover, all the post-operation process. And for sure, at some point in time, I'm not saying tomorrow, but maybe in 20, 35, we don't know, it will start again. So we will not need to, at that point in time, we will need to start again to know exactly where we are, and start not from scratch, but from what we left and from what we learned in those years. From the model, we have extracted all the 2D drawings, all the 3D drawings for the different purposes. Remember that we've been using the information to exchange the information with other different softwares for a specific matter. In these terms, we were talking about energy efficiency. So we were working on that specific matter. Remember that something that is very important when you develop a model is to understand what is the purpose while you are developing a model. So it means the model may contain the information you needed for that specific purpose, because you've got 12,000 cells, but you don't need to fill them, all of them, because you will not use them, all of them. So it's useless to spend time filling something that you will not use. It's important to use only the information you require. If by any reason tomorrow we will need further information, we will find a way to complete that information if required. If not, we would have done properly. We have done the model with the information we required at some specific moment, and with that information we worked on. And when I mean information, I mean the information that allowed us to calculate all the performance in terms of transmittance of the external envelope, meaning slabs, glazing, walls, and roof. Of that, we put that on some different softwares for to analyze the effect of the sun, all the sound performance, all the wind effects that goes into the building. Analyze also in another software all the daylight factor, how it affects the interior space. We use the model also to create the monitoring system. We develop a model. This is the model, and this is how it looks like. It's quite similar. As you see, we've got all the colors and everything. It was a code that we established since the beginning to make difference between the type of wire that it runs inside each pipe. Since we are not the electricians, we thought of developing it just to have a visual tool to understand exactly how and what information is running inside the pipes. So we've got the yellow ones that are the power. We've got the green one that has the Modbus that are carrying data, and also analogic data that run inside the gray pipes. And we've got all the different sensors that we are measuring, but we're measuring the building performance and the comfort, indoor comfort quality inside this room that is where I am now. To start planning, we have to understand exactly where were the problems of the building in different matters. So we analyzed it in different softwares. We saw what was going on in terms of illuminance and overlit and how it performed in the different times in different hours of the year. We analyzed also the sun radiation going to the south facade and the north facade to understand if it was correct, how we can perform to act regarding it. We also run the information in virtual simulation softwares where we realized that the consumption was high, and it was confirmed by the energy audit that we ran. And then we start thinking about what we believe are the quality indicators, what we would like to achieve in terms of energy efficiency, and we run different simulations. But when I mean different, I mean plenty, because as a sort of a research team, we were able to explore plenty of them. I'm not going to show you all of them because otherwise we'll finish maybe tomorrow, not even tomorrow, next week. But with all of them, we run different conditions and to see how, with the different approaches we've got, we compare, for example, how it performed in the new version. So we've got, for example, the original one, we've got a very impact on with the south solar problem, and then we reduce it, covering it with different elements. When I mean different elements, we mean a shading element going here. We open skylights on the roof, and you can see the difference between the problem that we had here with the lighting overlit near here, and now we've got a very more diffuse lighting in the entire floor. Different shapes, different problems, different results. We as I said before, we run crazy testing many and plenty different shapes, different solutions, just to not even thinking in if they were beautiful or not, just thinking of a functionality and a specific energy efficiency, just to test the different software and to test the information transfer between the different softwares. We start working also on a digital twin. This is part of what we are now measuring in real time on the building. We've got also our meteo station, and now it's everything connected to our model that is on a public side of the university with the help of the software engineers that help us to create our first version of the digital twin, which now is receiving in real time all what is happening here and all the sensors. We are archiving that, and we are now starting to match up all this information with the idea to create an app that can help the building managers and the students or whoever lives a building have a building experience to understand what's going on, because we need to inform everyone what's happening. It's not something that just information is there and it will be for us. little bit for everyone, because we need to teach the students as well that every time they open a door or open a window, something changes in a good way or in a bad way in terms of energy performance. Everything we do have an implication. So we are also doing a survey, collecting all the subject, the non-objective information, the subjective information, to understand how is the perception of the person against the information, the real data measured by the sensors. Because one thing is what the sensor measures, 23 degrees. 23 degrees, what does it mean? People at that time were having cold, were feeling hot, were hungry, were sweating. We wanted to understand exactly how the performance of the building do affect or do or is felt by the people who is inside the room. This is the pilot project. Now we've got the first authorizations to go through, and this is what we are going to build in the following months, install in the following months. This is exactly how it was. And this is the first digital twin that you'll find online with all the data I showed you before. This is the DINFO, that is the Department of Informatic Engineering that helped us to develop all this. And this is already online there.
Excuse me,
This
sorry,
is-
can I ask a question? You mentioned that this is available online. It is open. We can download and the model and the data that you have used, or not?
You can see the data there. You cannot download it. Hold on a second.
Yeah, okay.
No, because I want to show you. This was a link. If I go here, you can see my.
Yes, we can see you
My
open
screen?
the link. Yeah, yeah.
Okay, now I open the link, and you can see there is the building with the data. You can see it there, and you can just see the building. You can see all the sensors in here. And you can see, see exactly these are all the sensors that we've got inside. And you can see, you can see what you want. This is the last 4 hours of this sensor specific. It's just the only. But then you can see, for example, the temperature, how it runs, and now it's getting colder. And this is the last 4 hours of the measurement of this sensor.
So this is really interesting because we can have the real-time data. Because I can say, yeah. Thank you.
So that's the first approach that we have developed. We are getting there. We are going to mature it because, of course, we started from nothing. This is the stage where we are now. Further on, Giacomo will explain you even more in detail the scientific part behind it, because it's more complex than it is. And if you want, I can show you a quick sample of another version of how to use BIM, how BIM was used in a specific project. Or if you want, we can stop in here now.
No, we can have another example. I think it will be interesting to see the differences, or you mean a different case, a different building, or?
Okay, let me run quick. This was the St. Pancras station at London, where they wanted to install the information totems. Yeah. So they start planning everything. Okay, what we should do. They start thinking of doing. It's not something complex. It's something very simple. The installation of these elements on the station to guide the people who's using the station. It was very simple. There were 8 elements on one side of the station and 8 in the other side of the station. So they started with the project. Everything was sequential. Everything was completely linear. traditional way. There was no problem. Everything was planned. Okay, started with the project, and that's what they've done. It was chaotic. It was they start making the holes where they cannot. They drilled on the structural elements. Then the elements were not connecting properly with the cabling that was supposed to arrive. And they had a lot of problems. They had a lot of delays. And the rework cost a lot. They had a lot of extra work, nearly 1800s of extra costs. So then they decided that it was something wrong in there. Someone proposed, why not to think about using the BIM model, where we shared all the information, everything will be there. We will not overlap one to each other. We will find the best solution, where to drill, where to pass the systems, how to connect them. Then they said, okay, it seemed was supposed to be more expensive, but they were keen to try because they had spent a lot. They were promised that it will be better. They were very unfaithful, to be honest, at the beginning, but they were keen to pay for the extra cost of the design at the moment. Then this is what it comes. Then the clash problem was detected on the virtual element. Then it was replaced, it was modified, because everything was there on 3D. So you see the BIM model, the information model, was not of the entire station, was of that specific section of the elements to introduce the totem. So then we need to understand exactly what's the information we need to produce to be sure that we are not going to overload of information something completely useless. So if you see, the information of the model was very little. And this is exactly how it came out from the works. It was, they saved 1800s from the budget they proposed at the end of the day. So it means something that was supposed to be very cheap and very easy at the beginning was very expensive at the end. Something that was supposed to be very complex at the beginning represented a lot of savings at the end, because it was done properly, it was shared, it was a very collaborative first approach from all the different teammates. And then it's how it was. The savings were there, and somehow they re-enter on what they were supposed to spend at the end of the day. So a buildable design means cost savings, because if we invest more in the planning, in the project, in the collaborative process, sharing information all together as a team, where the costs are important, that are on the side during the construction and during the operations, they will represent savings. Savings of money, savings of energy, savings, and they will be also sustainable. And then
can I ask something about this example? Sorry. You mentioned that you didn't use BIM for the whole building, but the specific location of where they were going to be implemented, correct?
Yes.
Yes. Yes, but how did you select the diameter, as you can say, of the location? Like you chose the dimensions of a specific location, but how did you know that it could be implemented to a slightly bigger location?
Okay, you have knowledge of what you are going to install, because the totem has its dimension.
Yes.
has
But
its own installation plates. So it was 1 meter by 1 meter. Let's make an example of it. So I will not make the model 1 meter by 1 meter. I will make it maybe 2 meters by 2 meters or 3 meters by 3 meters. Yeah, it means it's going to be bigger than the area I will cover, but it will not be bigger enough to make me a problem, and it will be big enough to allow me to see the problems a bit more than the only specific element that I will go through.
Exactly. So is 2 times the area that the element is going to be placed enough, or 3 times the area?
Exactly. But then you plan of it. You say maybe 2 times is enough. Maybe let's make a little bit bigger. It's 2.5, the real good area. We will spend time in that, but will assure us that the result
you
will
make
be
different
warranted.
scenarios.
Exactly.
So you have to make different scenarios in order to reach.
Exactly. That's why I was saying about the objective and the needed. You need to plan also this. The building of a virtual model is exactly the same as the real model. If you are going to dig somehow to place the elements, you are not going to make the whole exactly the size of it. You always have to go a little bit bigger so you can just pass all the connection elements, all the plans, all the systems that you can allow you to work on it. Once you have done your work, you will close it. Of course, you have to go a bit farther on it. Even in the real hole, you will not go 50 by 50. You will go 70 by 70, and then you will use only 50 by 50. But you need to put your hand. You need to move the tools. You need a bigger hole. It's like the door. When you make the hole for a new door, the door passage, the free area will be 90 centimeters. But the hole at the time that you open it on the wall, it will be maybe 110. So you will have enough space to put the frame, and then you close what goes after the frame. I don't know if I explain it clear.
Yes, it is clear. So we always have to think about the surrounding space.
Exactly.
To calculate it when using it, because it doesn't only have to be about the specific model or totem as you mentioned, but there is also the surrounding space that needs to also be calculated in and also used.
Exactly. Just to make an example, once I was called to develop a BIM model with no information more than geometry of an entire site and the entire road and the mountain that was in the surroundings to arrive there and perform all the path of the curves of the lane with a special loading truck that was supposed to go in there, turn in all that road, get into the site, leave the elements that were carrying, turning out inside the site and returning back. But we needed to be sure that that truck was able, the most important, to arrive to the site and to turn it back. So it was only to test the path of the truck. And when we said, okay, it's fine, the truck will manage the way to get out of there, to get in and get out of there, they accepted the project. Otherwise, it was something not feasible because of the dimensions of one truck that will carry a specific product, a big size product.
Yes,
So
it's understandable. Yeah. So yes.
It means you have to dimension the needs of the model. So you need to understand what is the reason why you are going to develop a model. And then you will need to put there all the information required for it. That's why here, this is the closing one. The adoption of BIM methods and tools is often seen as excessive expenditure of resources. But the starting point is always to define the purpose and the objective of the model. If we have clear that, we can define that what you were saying, because it's useless to build up the entire station, and it's useless to have only one portion of 50 by 50. So you define it, you get it clear, and then you go through it, you develop your model. I don't know if
Thank
I'm
you very
clear.
much. Yes, yes, exactly. So yes, we always have to take note on this, as you mentioned, because calculating the whole bit is excessive. So we have to focus on the areas and the surrounding areas and calculate them accordingly.
Exactly. That's why I brought that sample, because that sample is very useful, because allowed, I still carry it because it allows everyone to understand that it's not only to build up skyscrapers. You can use it only for very small things, but that can really represent also savings in terms of time and costs. There's no big beam or little beam. There is just the way how you apply it to a specific project, to a specific matter, to a specific purpose. And if the organization has clear how things should be, everything will flow easily.
Okay, thank you.
Okay, so I think I'm done now. I don't wanna annoy you anymore.
It's okay. So it was a really fruitful presentation, and I think that at least for my side, the second example really showcased that the thing that you mentioned earlier, that we have to understand how BIM works, that it's not only for skyscrapers. That will stay with me, that how it is used and how it can be used. So I think at this time, if there's no other question, I don't know if anyone else wants to add something. There's still some people with us, so this is good. And I think we can stop this for today, if you don't mind. And so far.
No, nothing to add from my side. Thank you very much, Juan, for your availability and for this really interesting presentation.
It's always my pleasure.
Yes, of course. Thank
Yours
you, Dr. Juan, and of course, thanks to all the participants for having been here today and be present in our SEACAP forensic training session. And we will see you all, we hope, tomorrow for the continuation of the Metecosur project and its outcomes. So Thank you very much, and have a good rest of the day. We really thank Dr. Juan Olano for being here today and presenting us the BIM methodology. So thank you very much and goodbye.
Thank you.
Juan. Bye.
Thank you.
Everyone.
Thank you very much.
Ciao, Camilo.
Ciao. Ευχαριστώ πολύ, Παναγιώτα.
Και εγώ ευχαριστώ.
Γεια σου.
Γεια σου.